is awarded the World Food Prize in 2020, very recent. On behalf of trustees, staff and scholars of MS Swaminathan Research Foundation, we again congratulate you on this greatest achievement, sir. And his research is focusing more on soil carbon sequestration for food and climate security, conservation agriculture, and soil health. So his vast experience in the field will give a kind of an potential strategies which are applicable to enhance soil health, at the same time increase the productivity of crops in different folds. We, as foundation, we had an opportunity to work with him very closely in soil health management across 3 states in India in early 2000. So with his vast experience, I'm sure we will get much more insights from his recent studies to augment our own insights in improving the food production. Thank you, sir. Once again, we welcome you to this session, and now I hand over to you. We look forward to your talk.
Thank you so much. First of all, I want to convey my pranam to Professor Swaminathan. It's a great honor to see you, sir, this afternoon. It's also a great privilege to be invited to be a speaker today. In that regard, I also like to thank the current chairman, Dr. Madhura Swaminathan, and the executive director, Dr. R.S. Murali. I must also thank the former executive director, good friend, Dr. M. Valatham, very distinguished soil scientist, and the staff, Dr. Ranga Lakshmi, Dr. Raja Manikam, and many others for making this function happen. And I am greatly honored and privileged by the presence of Professor Swaminathan. I'll take a moment to share my screen so I can begin the presentation. I hope you can see the screen. The title I picked up today was Soil-Centric Approach to Realize India's Evergreen Revolution. And of course, as you will remember, the term Evergreen Revolution came from Professor Swaminathan. I'll like to begin with the historic development of population of India, which was merely 255 million United India at that time in 1800, and at the current population of more than 1.3 billion. Very drastic increase, and the population expected to be 1.7 billion by 2050, the world's largest country, and it will come down to perhaps 1.66 billion by 2100. So between 1700 and 2050, the population of India has increased by a factor of about 14, and it of course has a very strong environmental impact. And the environmental impact of population is given by the formula PAT, where P is population, A is the affluence with which the population lives, and T is the technology. So apparently affluence is going up in India because of the improvement in income and productivity. Technology is something hopefully can help moderate the impact, and that is something we talk about today. In the 50s and 60s, there are many doubts expressed throughout the world. The book Population Bomb by Ehrlich and several others indicated that the doubts, I have yet to meet anyone familiar with the situation who thinks India will be self-sufficient in food by 71, if ever. We had another book, Famine 75, by Paddock Brothers, indicating in 67 that India cannot be saved. Bangladesh is a basket case. And the truth, as you know, increase in agronomic production in South Asia, especially India, has not only been dramatic, but also largely unpredicted. And in fact, if you look at the inputs of irrigated land area, which at the moment net about 70 million hectare, the fertilizer consumption in India went up tremendously. Kilogram per hectare, almost 165, 170. India's pesticide consumption went up tremendously. It's about 56 million tons per year, almost 0.25 to 0.3 kilogram of pesticide per hectare. As a result of all this, and of course the improved varieties, the population in India at the time of partition was 330 million. The food grain production was 50 million tons. At present, population is almost 1.4 billion, and the food production is 300 million tons. So while the population has gone up by a factor of 4.2, the food production has gone up by a factor of 6. And this dramatic increase by a factor of 6, I would call appropriately the Swaminathan effect. It was his vision, it was his leadership, it was the crop varieties developed by him and Dr. Borlaug and many other distinguished plant breeders and visionary leaders in India that this thing happened, something that has made India food self-sufficient and food exporter. Yet the potential food grain production in India is almost 600 million tons, and I think that potential can be realized with the visionary leadership and the idea of evergreen revolution put forward by Professor Swaminathan. So India has become the world's second largest producer of both wheat and rice, and this grain revolution transformed the image of India from being a begging bowl to bread basket. And the credit of all that, of course, goes to the visionary leadership of Professor Swaminathan and several other colleagues. However, there has been impact on the environmental issues which we need to consider. Water quality is one, air quality is another one. Soil degradation was mentioned during the introduction. Water pollution, water quality, because we are using a lot of chemicals, fertilizers and pesticides. Erosion problem which impact both water and air quality. So this question is, how can India reconcile the need to advance food and nutritional security with the absolute necessity to restore and improve the environment? And this is where Professor Swaminathan's concept of evergreen revolution is very, very pertinent. Soil degradation in India, water erosion almost 64 million hectare, 40 million hectare by vegetation, wind erosion 9, water logging about 14, salinity and alkalinity 7 million hectare, acidity about 16, many other complex problems about 7, and total area somewhere between 110 to 150 million hectare. Many other factors like decline in organic matter content, extinction of species, endangered soil, extinct soils because of degradation, many other factors, nutrient imbalance, decline in soil structure, they are not even mentioned in this list. So soil degradation has been an issue. The management of crop residue in field burning, as you know very well, in northwestern India, twice a year perhaps, definitely in October, November, when the rice straw is burnt to prepare the seed bed. Rice husk in many mills is also burnt, impacting the air quality. For the last 10 years or so, the wheat yield has also been stagnant because of the soil-related issues. Hunger and malnutrition, unfortunately, still persists. We have almost 195 million people, 1 in 6, which are food insecure. By the way, that number is the same in the United States, 1 in 6 in Ohio, 1 in 7 in the country as a whole. Because there are other factors other than the production itself, which I'll come back in a moment. Urbanization in India is something to be considered in the planning, especially with regard to food security. Take the example of Delhi. Between 1950 and 2030, the population of Delhi will go up from 1.2 million to 36 million by a factor of 30. Calcutta would increase by a factor of 4, Bombay by 9, Pune by 10, Hyderabad by 12, Bangalore 21, Chennai by a factor of 10, from 1.4 to 14 million by 2030. And this is something that we have to consider. Brick making required for urbanization, especially in the Indo-Gangetic plains where there are no forests, no stones. Soils are mostly alluvial. Therefore, bricks, topsoil removal for brick making is an important component that impacts the quality of the soil as well as the productivity. Just to give you a rough estimate, it takes about 40,000 hectare average on a global basis to provide accommodation and infrastructure to 1 million people. India's population is increasing every year by about 11.5 million, and that requires approximately 500,000 hectare of land for urban and industrialization. By 2025, another 5 years, India will have 7 cities of more than 10 million population. A city of 10 million people requires 6,000 tons of food per day. That's a lot of plant nutrients coming into the cities and not going back to where they came from. In fact, they become a major liabilities in the city if they're not properly handled, and that is often the case. And yet the animal and human waste and the other bio-waste from the city could be used properly by recycling, taking precautions to make sure they are not health hazard, to produce perhaps 15-20% of the total food consumed in a city within the city limit. And therefore, urban agriculture obviously would require a considerable emphasis for future. I wanted to mention about the brick making. Here was a picture from Haryana. Tremendous impact not only on the soil, but also on the environment, something which should be done. And it is in this context that Professor Swaminathan came up with the idea of evergreen revolution. And according to the definition that provided by his thoughts and his visionary leadership, evergreen revolution refers to productivity improvement in perpetuity without ecological and social harm. The evergreen revolution involved the integration of ecological principles in technology development and dissemination. He actually had thought about this idea way back in late 60s and early 70s. He was very aware that indiscriminate use of chemicals and other inputs can have impact on the environment. Therefore, he came up with this idea. The concept was also supported by the then President of India. The Green Revolution can be converted into Evergreen Revolution only if there's a paradigm shift in our research and development strategy, leading to change from a purely commodity-centered approach to one based on an integrated natural resource management strategy. So here is Professor Swaminathan's vision that it's not just the plant variety, is the integrated natural resource management, which is the crucial part of the food production. And that was the support that President Narayanan provided to the idea of Professor Swaminathan's Green Revolution concept. So that brings me to the question, how would India feed itself by 2050? Indeed, India produces enough food already. Thus, food and nutritional security really has many other parts which also need to be addressed, not necessarily in production. Reducing waste, which may be as much as 30 to 50%. By the way, that's the global figure. The same figure applied to the United States. Different processes involved in the waste in terms of developing and developed countries, but the amount is about the same percent. 1 ton of food saved from wastage is better than 1 additional ton produced. I think this concept of saving food, having lower post-harvest losses, especially in the northwestern India that you notice, is an important aspect of security. Increasing access to food by addressing poverty, inequality, civil strife, political instability, and of course these days lockdown due to COVID-19. These are major contributor to food insecurity. Improved distribution, of course, increasing use of pulses. I must mention when I read that India's animal-based diet is increasing at the rate of 10 to 15% per year with increase in income. That's a kind of a concern because we should focus on plant-based diet, therefore using pulses as a source of animal rather than animal protein. Using pulses as a protein would be a good choice. It's a part of our culture and we should continue. Accept personal responsibility of not wasting and not degrading natural resources and not taking things for granted. Increasing agronomic productivity from existing land. Restoring degraded lands. Increasing biological nitrogen fixation by legumes. Protecting prime land against urbanization and brickmaking. Returning some agriculturally marginal land back to nature through eco-intensification and restoration of soil health. So that's the focus, how to improve and restore soil health and adopt eco-intensification. Therefore, the 20th century green revolution or the evergreen revolution, rather than input-based fertilizer, irrigation, pesticide, it must be really soil-based. Soil resilience is important part. Ecosystem-based, eco-efficiency of the inputs used, and knowledge-based, science and management-driven. And those concepts were exactly the same that Professor Swaminathan put out in his slides of the evergreen revolution. Soil management, which is the most basic factor of production, putting in terms of economics, and the biophysical properties, the chemical properties, biological properties. These are determinants of soil health, which are based on the critical level of organic matter content. And sometimes we try to compensate that loss of soil health by poor management by putting fertilizers. But soil fertility cannot be managed just by adding fertilizer. Soil compaction cannot be eliminated just by deep plowing. Drought cannot be mitigated just by flood irrigation. Erosion cannot be controlled just by installing terraces and making bunds. Acidity cannot be neutralized just by liming. These are symptomatic treatments of the problem. We must improve soil health, and the major determinants of soil health is soil organic matter content, which should be about 3 to 4% in the root zone, top 20 to 30 centimeter. Unfortunately, as I will show in a moment, in soils of India, especially northwestern India, in the Gangetic Plain, it can be as low as 0.5% or less. So if we were to look at the optimum range of organic matter content in most soils in the root zone, about 3% or so, at the moment, most soils of India are somewhere less than 0.5%. Therefore, we try to compensate that loss of organic matter content by adding fertilizer, by adding irrigation, by adding pesticides, and that is not the best option. That's not the feasible way to improve soil health. That's a temporary band-aid kind of concept, not the basic how to address the soil health. Improving soil organic matter content, which is not an easy path, but that's exactly the pathway we have to go. And the way that is done is what we call the law of return. The law of return says that we must replace whatever we remove from soil, respond wisely to whatever is changed, and predict what may happen both by human and natural intervention. And we must restore soil quality and functionality. And those are the critical components. And this is what we call eco-intensification. The strategy is to produce more food from less land, from less water input, from less inputs of fertilizer and pesticides, from less use of energy, and from less emission of greenhouse gases from the soil. And those are the things that requires judicious management of soil. It requires improvement of soil health, and that was the concept that was indicated by Professor Swaminathan in his concept on evergreen revolution. That brings me to the definition of what is soil. And I go back to the concept of soil that Charles Kellogg put out. Essentially, all life depends on soil. There can be no life without soil, and of course, no soil without life. They have evolved together. I will go a step further and indicate that the rhizosphere, that the soil root interface at a nanoscale, is the only site in the universe where the death of biomass is transformed, resurrected into life. That soil, Dharti Mata, had the divine power to convert dead organic matter into life. And I think that comes through the concept of soil health, that soil is a living entity. Why had the organic matter in soils of India declined? Because we take away more than we put back. Remember, I had law of return, replace what you take away. And if we maintain a balance, the input of organic matter into the soil by biochar, by compost, by cover crop, by roots, by crop residue, must always exceed the losses by erosion, leaching, decomposition. And for each site, each region, each province, this balance must always be positive. Unfortunately, under current situation, the way we manage inputs of carbon into the soil versus the losses are much less. Therefore, we are continuously depleting the soil's capacity to provide ecosystem functions that we need. In fact, I calculated from basis of many crops and many sites, many experiments, that if we can increase carbon in soil, organic carbon, by 1 ton, for the same inputs of fertilizers and irrigation and other inputs, the corn yield can be increased up to 300 kilograms per hectare, soybean about 50, wheat about 70, rice 10 to 50, sorghum 80 to 140, millet, beans, all crops, their productive capacity goes up. And we can increase almost 10 ton of carbon per hectare over a generation time, about half a ton per year extra. That data shows from many experiments in India. And that can increase not only the production, it will decrease the necessity of dependence on fertilizers, but at the same time, it will improve nutritional quality of the food, because nutritional security is also very important. So my philosophy is leave the crop residue on the ground. Here was winter rye suppressed, and then corn planted through it by no-till farming, grow cover crops, especially if they are legumes, and they fix nitrogen. Therefore, the concept is not NPK. The concept is CNPK. C comes before, put biomass return back to the land. And if that's the case, the dependence on NPK would go less. So I would emphasize not NPK, but CNPK. And that C, if it's done better way, can certainly reduce the dependence on fertilizer. And one of the concept of achieving this, of course, improved varieties. They are very important. And these varieties such that they have a better root system. Root system is one which is mycorrhiza. Uh, it should have a deep prolific ability to explore water and nutrients, especially micronutrients. We must, of course, use mulch, not burning the crop residue. We must try to grow forages, especially leguminous, which will build up the soil fertility and crop rotation. And we must integrate crop with trees and livestock. I think this process will also create disease suppressive soil. When soils have very high biotic activity, they also have predators that feed on pathogens, and therefore these soils, we call them disease suppressive soil, very high biotic activity. Yes, for high yields, we might require water and nutrients, especially micronutrients, but they must be applied precisely and directly to the plant root through drip sub-fertigation. Drip irrigation with fertilizer applied at a time when needed and how needed, so that most water and fertilizer nutrients are absorbed by plants and not leaked into the environment. The use efficiencies of fertilizer in India at the moment, in a best case scenario, maybe 30%. Therefore, developing technology, we are feeding plants directly into the root zone through fertigation rather than flood irrigation and broadcasting nutrients in it. If we were to adopt regenerative evergreen agricultural practices, mulch farming, not burning residue, vermicompost, cover cropping, returning the biomass, better root system, integration of crops with trees and livestock. Irrigated land area right now, 70 million hectare, using 200 kilometer cubed of water, can be increased by 2030 to 75, reducing water use 2050 to 82, about half the water than we use now, and by 2100 to 100 million, and decreasing water use further. So the idea is decrease water consumption, increase efficiency, expand the area. Fertilizer use, 30 million tons now. It should be reduced to no more than 15 by the end of the century, and no more than 20 by 2050 if needed. If needed, use it properly, not solely depend on fertilizer. In-field burning of residue, the rough estimate, we burn about 100 million ton now. Hopefully by 2030, it's zero. No burning of residue, returned back to the land. Pesticide use, 56,000 tons. At the moment, it must come down to, remember I mentioned disease suppressive soil, hopefully no more than 10,000 tons if needed. I hope it's not needed. Cereal yield can certainly be doubled, only improved varieties, and better soil and water management and fertility management opportunity. Improved varieties potential can only be realized if they are grown in soil which are healthy and have very good support processes for plants. Post-harvest losses at the moment approximately considered 1/3 in India. By 2030, hopefully we can decrease to 10%. Eventually no more than 5%. Some losses are a part of the system, will happen, but 34-40% is certainly not acceptable. So the idea is to increase the organic manure. 200 million tons used at the moment, should go to 300 and 400 million ton by 2030 and 40, with an aim of 500 million ton. So we increase recycling of the bio-waste and therefore decrease the dependence on the chemicals over time. This can happen. So these three components, fertilizer, burning of residue, pesticide use, we should decrease as soon as possible through policy intervention if necessary, and that has direct positive impact on soil health. Soil carbon and sustainable development goal, it was also mentioned during the introduction. Soil health has a obviously very important impact on ending hunger. That's sustainable development goal number 2. Climate action, tremendous impact. Globally, we can put in about 180 gigaton of carbon in the world soils between now and 2100. And vegetation, restoring afforestation, we can put in another 150. Together, about 330 gigaton of carbon could be put back in global terrestrial biosphere, land and vegetation, which is about 150 parts per million of drawdown of atmospheric CO2. At the same time, we must reduce fossil fuel consumption. So life on land, the concept that UNCCD has come up with, land degradation neutrality. India last year had a meeting in Delhi with UNCCD. They made a commitment of 26 million hectare restoration of degraded land. I think we should stay on that path, on what we just talked about, improve the productive good land and save marginal land for nature and restore it in terms of its ecosystem services. There are some other sustainable development goals and poverty. With majority of the population still dependent upon agriculture, obviously improvement in agriculture can have an important impact on poverty alleviation. Good health, goal number 3. Goal number 6, clean water. Water, when it passes through soil, that is the best filter, not only denaturing pollutants, but also filtering the pollutant out of the water. And renewable energy, again, biomass properly used, not through direct combustion, but certainly other means, bioenergy can be very important. So how do we protect the soils of India and soils of the world? One is to teach, promote, advance the concept of stewardship. In a way, what Professor Swaminathan and President Rattan said was exactly that, stewardship concept. We can provide economic incentive, and we can also create legal approaches. The last legal should be the last resort. I think we can talk to farmers and provide economic support to farmers. That would be the two best options. But let's briefly talk about stewardship. Our epics, our scriptures, our religious books, they all talk about stewardship of soil, Dharti Mata, Vasundhara, Prithvi, Bhumi. We worship it, but we need to translate that into action. And that means soil stewardship and care must be embedded in every fruit and vegetable eaten, in each grain ground into the bread consumed, in every cup of water used, in every breath of air inhaled, in every scenic landscape cherished. We must teach this concept at all levels, from primary school, secondary school, to the postgraduate level. And of course, all our religious organization, whether it's a synagogue, whether it's a church, whether it's a temple, whether it's a mosque, whether it's a gurdwara, each of those religious scriptures have one thing in common, and that's the stewardship, protection of the natural resources. The concept, should the food price reflect the degradation of these entities? Probably in a poor country, not, but certainly if we degrade soil, the cost of that should be considered very carefully, and the society somehow has to pay. And that payment can be to the farmers also. If the farmers in India are asked to leave the residue and increase carbon in soil, let's say they increase by 300 kilogram per hectare, that societal value of that carbon translates into about 1,500 rupees per acre per year. And I think that can be, it's a support, it's not a subsidy. It's a support for creating ecosystem services, and hopefully farmers can be compensated. The third part, the legal part, rights of soil. I wrote an article in the beginning of this year in which I stated, just as universal rights of human, rights of animal, soil is also a living entity. Soil is the source of 25% of all biodiversity in the terrestrial biosphere. So soil must also have rights, just as rights of nature, rights to be protected, rights to be restored, rights to thrive and manage judicially. And that can come, I've been promoting that idea in the US, EPA we have a Water Quality Act, and we have Air Quality Act. It is not possible to have improved water and improved air unless there's a Soil Quality Act also. Environment is trinity of three things: soil, water, air, and therefore soil protection is equally important. Rejuvenating soil health in India, soil-centric program, conservation agriculture, integrated nutrient management, drip sub-irrigation, residue retention rather than burning, cover cropping and forages, and then of course governance and political, where you provide incentive to farmers for doing good things. I must say that peace and stability, we talk about weapons of mass destruction, but we really think that degrading land and denuding landscape, recurring drought and intensifying heat waves, low crop yields and perpetual hunger, marginal living and desperateness are actually much bigger threats to global peace and security, and they must be effectively addressed. These are the land-based solutions. When people are hungry, they are desperate and miserable, they pass on their sufferings to the land. And unfortunately, land reciprocates. People are mirror image of the land, and you can see that relationship between land and people everywhere. You drive through sub-Saharan Africa or through the Caribbean, and you can see that relationship. And you drive through the Midwest United States, and you see that relationship very clearly. So people and land, they go together. If we can improve the health of soil, health of the environment, the health of people is improved with it. And that's the concept that I've been promoting. The health of soil, plants, animal, people, and environment is one and indivisible. If the health of soil degrades, the health of everything else degrades with it. I think we need a paradigm shift, not only in India, but globally, going back to the concept that Professor Swaminathan proposed, Evergreen Revolution. To answer the question, what would I suggest to make land management a solution to environmental issues? The logical response would be to objectively and critically consider how we take land resources for granted and use them as a personal property. A prudent strategy would imply making land, that is soil, water, air, and agriculture integral part of the solution, and empowering farmers. And in India, these are poor farmers, 2 acre, 5 acre, 10 acres. Many elsewhere in Southeast Asia, as well as in Africa and the Caribbean, these are generally women farmers. So empowering them and empowering land managers to restore degraded lands, to afforest the denuded land, and return some marginal land back to nature. That's the law of return. We must return some land back to nature for other species that we inhabit with the planet Earth. It would be impossible to keep global temperatures at safe level unless there is a radical transformation in the ways by which humans produce, consume their food, and manage the Earth's finite and fragile land resources. We must go back to the concept of Evergreen Revolution, which is based on sustainable management of soil, water, air, and biodiversity. It has been a great honor, especially to be able to present a lecture today in presence of Professor Swaminathan, and I'll be very delighted to answer any question that you may have. Thank you.
Thank you very much, Professor Lal. It was an extremely insightful and invigorating talk. And in fact, every slide of yours had such a wealth of information. It was amazing to see the wisdom that you are sharing with us today. We are indeed privileged. Professor Swaminathan is also listening in, and we are opening up now for question and answers from the floor. I have a question from Dr. Arvind Padi. Existing soil health schemes of India are aimed at balanced use of fertilizers and not much on enhancing soil organic matter carbon. What would be your advice to the government for course corrections, sir?
Thank you. I think, as I mentioned, the need for fertilizer keep going up as the soil get more and more degraded. And therefore, I am recommending the idea of CNPK. If you want to use it balanced also with C. Of course, adding more nitrogen and not P and K is also a serious imbalance, and that has created many problems. But not having attention to carbon, organic carbon in soil, is a major issue. So I would encourage change in policy, reward farmers, those that return the biomass, they increase soil organic matter content, reward those farmers. Those farmers who burn the crop residue and use chemical fertilizers instead, probably they cannot be rewarded by subsidies because subsidies are hurting, wrong subsidies are hurting the environment. So improving soil organic matter is the highest priority of restoring soil health. With that, if we can increase the organic matter content from less than 0.5% now in most soils to 2%, 3%, and that will take a generation, maybe longer. That will reduce the need for chemical fertilizer drastically. So my recommendation will be focus on organic matter content, and then whatever additional is needed, use that as a supplemental.
Thank you, sir. In fact, related but more from the point of view of a global perspective is Professor Jayaraman's question on, from the point of view of common but differentiated responsibilities, what is the prospect of countries like the US, Canada, and Russia taking the lead in improving soil health? It would perhaps inspire other nations to follow suit and also provide useful technological leads.
I think that's a good suggestion. In 2007, when I was president of the Soil Science Society of America, I had proposed a soil protection resolution. And with the help of 6 senators, soil protection resolution 440 was accepted by US Senate, but it never got translated into an act. So a resolution is non-binding, but an act is a binding part. I think it's not only these countries should take lead. I mentioned that in a discussion we had yesterday with Patagonia, that we also need this throughout the world. And India, being very emerging, important economy, very soon the most populous country, should really become an example also, because we have small landholders, which is the norm throughout the region in the tropics. India should really take a step in developing a soil health act, where those farmers who restore and improve soil health by recycling organic matter, by improving and sequestering carbon in soil, making sustainable soil and agriculture solution not only for food and nutritional security, but also environment, they should be rewarded somehow. I heard the other day a figure of 5,000 rupees per acre. I come up with 1,500, but something that farmers who are doing good things, they should be rewarded. So it's not only the developing, that developed countries, US, Canada, and European. I think India probably has the best know-how, and Dr. Swaminathan came up with the idea of evergreen revolution, which I perfectly support. It's a great suggestion. We must implement it. India can take a lead, and I hope it does.
Thank you, sir. From Dr. Carlo Fada, who spoke at the previous session, who has continued to stay on with us, thank you for that. This was a very inspiring presentation, thank you, he says, and asks, do you have any specific cases of PES for soil schemes around the world?
We have, if I understood the question correctly, you're looking for whether what the carbon critical level is, if that's the correct interpretation. most soils of the temperate region should have soil organic carbon content about 2%. And organic matter and organic carbon are related. Organic matter is about 50% organic carbon. So if it's a 2% organic carbon, organic matter content should be about 4%. In temperate region soil, where building and maintaining organic matter content is more difficult because of high temperatures, like in India, the critical level is slightly less, really somewhere between 1.1% to 1.5% organic carbon, which means critical level about 2 to 3% at the most. Right now, as I said, soils of India, when I said 0.5%, in fact, I have seen soils of 0.1% carbon, which means 0.2% organic matter. This kind of research is very important. Long-term experiments were started in India during 1908-9. In fact, at Coimbatore, 2 experiments were begun in 1909. There was an experiment at Pusa. There was a long-term experiment at Kanpur. These long-term experiments should have provided a lot of information. Unfortunately, some of them, we lost them. They are not continued. The one at Coimbatore is still being continued, and I hope it will be continued forever. These long-term experiments should guide us how management can improve soil health. I think there's a lot more that need to be done. We need to find out how much organic carbon crop residue should be returned to maintain a status quo in soil. It maintains stability of organic matter, but at least how much is needed to increase by a certain amount, like 1 ton, half a ton of carbon per hectare per year. And farmers should be compensated, rewarded for doing that. India has a very strong research network through ICAR and through many universities in India. And I think with coordinated effort, this information can be put. I have come up with the idea perhaps we need every 5 years soil health report published for India. That should be a very good idea. How are we making progress? My suggestion, landmark I suggested, hopefully can be discussed in that report when every 5-year report is given.
Definitely, sir. We will take that very important point forward. There's a question from and a couple of comments from Mr. Ravichandran, a farmer, who wishes that the soil health card includes carbon and biomass also. Plus, it is silent on micronutrients, he says, and it should have a total soil profile. I think that was partially answered already by your question. And he says he's experimenting with growing rice in drip, and those who use less water must be given carbon credit. So I think that also you have partially covered, sir, but if there's any specific comment you'd like to make to Mr. Ravichandran.
Absolutely. Mr. Ravichandran is an example of a very good farmer, very progressive farmer who has an insight. And I think scientific community should really have very strong channels of communication with progressive farmers. Like in micronutrients, I mentioned 17 of them. They are essential for human health. And most of our soil, especially iron, zinc, selenium, molybdenum, many of these micronutrients are deficit. We really need to pay attention to it. Again, organic matter content, because of its surface area and electric charge, is the best way to improve them. I want to come back to the point that I did not discuss aerobic rice, and the farmer just mentioned that. Yes, flooded rice is not the best option. Aerobic rice, based on very good improved varieties, which can be grown as an upland crop. I agree that the yield will be less, maybe 10%, maybe 15%. That is where we can compensate farmer for the loss of yield through ecosystem services payment. And farmers should be rewarded for growing aerobic rice. It saves a lot of water resources. India's consumption of water resources for irrigation is very much. And I fully support this idea of aerobic rice, unflooded direct seeding, farmers to be rewarded for doing that.
Thank you, sir. The next question from Dr. Rajiv Varshni from ICRISAT. An excellent talk, sir. It is always a feast to hear you. It is absolutely right as you highlighted the role of soil management for achieving an evergreen revolution. I'm wondering when we can develop soil varieties and soil management should be targeted as a breeding criteria for improved varieties. So we should have good collaboration with soil management and agronomy folks. Your thoughts, please.
Thank you. I think the collaboration between soil scientists, agronomists, and plant breeders is absolutely essential. As I mentioned, plant varieties were the basis of the Green Revolution. And I must thank Professor Swaminathan and Dr. Gurudev Ghosh and Dr. Vassal and Dr. Raj Paroda and many other outstanding plant breeders that India was blessed to have. But now we have reached a stage where the potential of these improved varieties can only be realized if they are grown under ideal soil conditions. Therefore, the plant breeders and agronomists and soil scientists working together is absolutely critical. In a way, soil scientists should discuss with plant breeders what is expected from us in terms of requirement in a variety. Like I mentioned, deep root system, more suberin content in roots so that they does not decompose very quickly. The harvest index, which was very important in terms of the grain productivity, but we also need harvest index in favor of biomass, especially the root biomass, so that the soil health can be improved. I would like to talk to plant breeders and ask them to be able to give us the varieties which under stress produce molecular-based signals. And there are examples of that. When there's a drought stress, what kind of signal can be produced? If there's a deficiency of micronutrients, what kind of symptoms, molecular, which we can detect in advance and intervene to alleviate that constraint and so that the loss in productivity is less. I hope that this integrated team approach of plant breeders and soil scientists, along with plant pathologists and entomologists, so that we can minimize the dependence on pesticides and chemicals. By working together, we can do that. Very good idea. I fully support it.
Thank you very much, sir. Since there are quite a few questions, I'll take just quickly run through the next couple of ones from Dr. Mehtab Bamji. What are your views on vermicomposting? And Dr. Ram Janakiraman, can we train farmers to collect soil data as frequently as possible and link them to local agricultural experts to provide timely advice on what to grow, how and what inputs, etc.? Yes, sir.
Thank you. Yes, vermicompost is a great idea. In fact, I visited some of the experiments being done by MSSRF along with Professor Vilayatham, and I saw those. Yes, that's a great idea and we should encourage. Farmers must take active part in soil health evaluation. And here again, I go back to Professor Swaminathan's idea when I talked to him many years ago when we were talking what is a soil health index. And it was his idea that soil health index is something that scientists can quantify, but farmers can understand and relate to. And that's a great wisdom. Farmers cannot really talk organic matter content, what percent, but from the color of the soil, they can understand a soil, a darker color would be a healthier soil. From some indication of the worm population in soil, farmer can see that that soil quality is good because it's supporting earthworm population. Yes, farmers should be able to sample, and farmers should be taught how to interpret the data that they get. That communication between scientists and farmer is very critical.
Yes, so definitely noted. We have to communicate more with farmers. Science must reach the farmers. The director IARI has asked, recycling of residue has to be technology based. What innovative technologies would you like to suggest?
You know, thank you, sir. I'm really grateful that Director IARI is also present today. Why are the farmers burning residue? They are burning because they really do not have the technology to manage it. And what is the technology to manage? We got rice residue, maybe 4 or 5 tons, maybe more wet on the ground. It has to be somehow managed. So the combine that they rent now cuts the residue at a very high level. Then whatever is left behind, there's no machinery to manage it. So if at a village level, we have a machinery to cut the residue at a ground level, to bale it perhaps, and we have machinery to seed through the residue, this kind of technology should be made available to farmers on a rental basis so that they do not have a need to burn. That residue could be composted and then returned back to the land. I think this is the kind of machinery availability must be made at the village level. Whether it's a private company, whether it's a government, they should provide that machinery and they should maintain that, but yet charge farmers, hopefully at a fair and transparent price so they can use it. So unless we provide the technology to manage the residue, farmers will keep burning it. That should become a very high priority. They should be shown that not burning the residue, composting it, returning it back to the land in a compost form is the best way for the environment and soil. It requires technological inputs that should be provided at the farm level to all farmers. And those who adopt it, we should support them. We should provide them incentive.
Yes. Thank you, sir. A few more thanks and wishes to you from Mr. Murli Gopal, V.S. Chandrasekharan, Mr. Devraj, Sheetal Patil, and Jagan Shekhar, and also a few questions. Dr. Suman Sahai asks if Professor Swaminathan can forward Professor Rattan Lal's suggestions to the Prime Minister for action. These are excellent ideas that should not be lost. Noted, ma'am. Also, from Dr. Padi, what would be your advice to government on rationalizing fertilizer subsidies? Thank you, sir.
I think this is a very good idea. Subsidies were very important. We have been subsidizing nitrogen, and therefore farmers were not using phosphorus and potassium. We were at some point in Punjab and Haryana subsidizing electricity so that the farmers could use as much water as possible. Sometimes wrong subsidies can also be a problem. And then desubsidizing something that farmers get used to obviously has political connotation. So subsidies should really be replaced by payment for ecosystem services. When farmers do good things, they should be rewarded. I think that dialogue should take place under the leadership of Professor Swaminathan and Dr. Raj Paroda and Dr. Mahapatra and others in ICR at the government level. Technology, knowledge exists. The idea is translating into action, and action which is pro-poor, pro-small landholder, and pro-environment. Anything which is not pro-environment would be really something which we should discourage and not continue. Not promoting through payment for ecosystem services is much better option than the subsidies.
Thank you, sir. From Marco Rondon, IDRC. Thanks, Professor. How do you see the prospects for using carbon trading as a way of using climate finance to incentivize farmers? Partially covered earlier, but specific to...
Thank you. Thank you. I believe that just like we grow wheat and soybean and corn and cotton, sugarcane, growing carbon is also a farm commodity. And that's what the carbon trading means. So the trading is if a farmer grows 1 ton of carbon dioxide in the soil, can that be traded? Yes, it certainly can be. If you go to Google Chicago Climate Exchange today and find out what's the cost of carbon trading in the United States, unfortunately, is less than $0.50 per ton of CO2. The societal value is not $0.50 per ton of CO2. Societal value, the benefits that the community receives from climate change mitigation, water quality, reduction in use of fertilizer, that price is different than the market price is. So unless farmers are given the societal benefit price, carbon trading cannot be effective. So it is not the question of demand and supply. If the demand is little because everybody can burn the fossil fuel as much as they want, who will then want to buy something from farmers? So first we think about how to create a demand, and then we make sure that the farmers are paid just fair price, which is a societal value, ecosystem services price. And economic price and ecosystem services price are very different. If farmers are not paid fair price, they will not do what we want them to do.
Thank you very much, sir. Maybe we will have one last question from Priscilla Marimo. Just for information, this was circulated only to, the Zoom invitation was circulated to limited participants. The live streaming on YouTube and Facebook is public and can be accessed at any time and shared. So we would definitely like to promote your talk much more, although this is to a select audience itself. Priscilla says, interesting presentation. Are there examples in India where farmers' knowledge on soil health is being harnessed and what methods are being used? Training manuals that can be adapted to other regions in any national action plans?
I think there are, I have kept in touch with several colleagues within ICAR network, and the soil health card, in fact, is a very good example from India that needs to be adopted. My only concern about soil health is A, it is based on the surface layer, and B, perhaps the emphasis on soil organic matter content and what are its implications when it is lower, maybe less than what I would like to see. And also what is recommended to farmers to improve soil health, which should be done in discussion with farmers. So on a participatory basis, that part, when you are given a soil health card, what to do to improve soil health and how to make sure that the farmer actually follow through that implementation of the improved management practices, that part need to be done. It's not a soil health card just for the sake of soil health assessment. It must be translated into action, what farmers should do and how we support farmer to do proper agriculture. That part which I think requires some additional input. Otherwise, the soil health card concept is commendable, and I hope it continues and stays. It needs to be periodically checked for its applicability and how it can be improved, especially in relation to sustainable development goals and making Indian agriculture as a solution to the environment. With the tremendous food production, as I said, by a factor of 6 since independence to now, that's a great success story, something to be proud of. The environment, if we can improve also, it will make India as an example. And I hope it will.
Thank you very much, sir. Indeed, Professor Swaminathan just sends a message that he will be writing to you. He has been listening to your talk online, and he was very much looking forward also to your presentation. So he will be writing formally to you. And since some of the suggestions also relate to how we can advocate better for the points that you have raised today, we will do our best through this conference. On behalf of the Swaminathan Research Foundation, the staff and the management and the trustees, I'd like to extend our heartfelt thanks to you. It's not a convenient time. It's really early in the morning. But we were very excited and very glad that you could join us, and it has been an amazingly insightful experience for us. We look forward to being in touch, and hopefully we will document your talk and write back to you for further steps ahead. Thank you very much, sir.
Thank you.